So this is the beginning of the same thing we started with before. We've got isomers, which means they're made of the same parts. Constitutional isomers are put together differently. This was the example where we had ethanol and ether. We changed the position of the oxygen in the atom, and we get very different physical properties. Stereoisomers have the same connectivity, but they're not superimposable, so they're put together differently in space. That's why the stereo there. And now we're going to look at different types of stereoisomers. We can have enantiomers, which are non-superimposable mirror images. These have the same physical properties. Diastereomers are non-superimposable, but they're not mirror images. And so these will have, the diastereomers will have different physical properties. So let's take a minute and look at cis-butene and trans-butene. These cis and trans isomers are not mirror images, and so they're not enantiomers. If I put a mirror here, this does not mirror that. Okay, so they're not enantiomers. But they are stereoisomers because they have the same chemical formula and the same connectivity. So they are the diastereomers. So if a molecule has two chiral centers, that gives us 4 possible stereoisomers, 2 pairs of enantiomers. So let's look at an example. If we have hydroxy coming toward us and a methyl group coming toward us, we have an enantiomer where in this one, they're both coming toward us. In the enantiomer, they would both be going away from us. Remember, if we're going to draw the enantiomer like the mirror is behind the image, we'd end up with but we also have the possibility where the hydroxy comes toward you, one of them comes toward us, and one of them goes away. The mirror image of this compound, the hydroxy goes away back toward the board, and the methyl group comes toward us. So this is a pair of enantiomers, and this is a pair of enantiomers. When we look at the diastereomers, though, we take this one. It has a diastereomer here and a diastereomer here. And it's sort of like this is a twin or a sister, and these are cousins. So each stereoisomer has one enantiomer, a sibling, and then it's got these 2 cousins. They're just a little not quite as related. Okay, so this one has this as its diastereomer. Okay, so each one has a relation, and then it has a cousin. If there are 3 chiral centers, it gets even more complicated. So let's draw some figures. We'll start with the first one. They'll all be up. Here's a hydroxy going toward me, a methyl group coming toward me, and a chlorine coming toward me. The enantiomer for this would be, they're all going back in the board. So these two are enantiomers. But we can have other configurations. What if we have the hydroxy going toward us, the methyl group coming toward us, and the chlorine going away? Well, the enantiomer of that would be the chlorine coming toward us, the methyl group going away, and hydroxy going away. These two are enantiomers. And we have hydroxy going methyl away, chlorine toward. And the enantiomer of that just has them drawn in reverse. So these are enantiomers. And the last one I can draw is I can draw the hydroxy coming out, and the other two are going to go away. And the enantiomer of that okay. Now, if we take this one and we name it A has an enantiomer over here, B, but A has a diastereomer with all the rest. Okay, so there are 8 possible stereoisomers, 4 pairs of enantiomers, and then each one of these is related to the other 6, and they are diastereomers. So let's do a problem and see if we can figure out whether things are enantiomers or whether they're diastereomers. Okay. So enantiomers are going to be drawn, we draw them the same. This is up, here it's down. This is down, here it's up. So it's complete reversal, so that makes it an enantiomer. Look at the next one. Okay, if this was going to be an enantiomer, these are both up, these would both have to be down. That didn't happen here. So this is a diastereomer. They're related, they have the same formula and the same conductivity, but they are not mirror images of each other. And they're not the same molecule either. They're different. If we look at this one, these are both up. Here the chlorine is switched, and so this is also a diastereomer. Because if you rotate that bond, the chlorine would be on the down when it's rotated.